Hello, everyone. Good morning, good afternoon, or good evening, depending on where you are. We are very excited to have our Alluxio office hours today. So before we get started, just a few housekeeping items. One is we are recording this session, so you'll receive a link to both the recording and the slides when it is over. Second, we will be doing a Q&A at the end of the office hours, so we encourage you to bring any of your questions, even if they're not related to the topic we're talking about today. We encourage any and all Alluxio-related questions, and we ask that you actually join our Slack channel. That's alluxio.io/Slack. You can go ahead to that link and pop your questions into the Slack channel, and we'll be there answering questions. Alternatively, if you have any issues accessing Slack, there is a questions box on the GoToWebinar panel you can use as well, but we highly encourage you to go to Slack to join with our community as well as ask questions about the office hours today. So with that, I would like to introduce Bin Fan. Bin is our VP of Open Source and one of our founding engineers at Alluxio, and today he will be talking about how to improve memory utilization of Spark jobs using Alluxio. So with that, Bin, please take it away.
Thanks, Ali. Good morning, everyone. I'm glad to be here to present some latest exploration and some very interesting experiments we're doing to show you how Alluxio can help Spark jobs to improve the memory utilization. So, this is me. My name's Bin, and one of the founding engineers in the Alluxio team, and also the open source maintainer for Alluxio open source project. And this is my Twitter handle. So this is the agenda today. I will have a technology overview first to talk about what Alluxio is, in case people are not familiar with this, what Alluxio is providing, and then I will go to some reasons behind why we see a lot of users running Spark on Alluxio for what kind of benefits they can get. And in the end, I will come up with a demo, show you how Alluxio can improve the Spark job memory utilization and how to achieve that. First of all, this is the Alluxio overview. So Alluxio is a data orchestration layer for the big data and AI workloads. So if you see this is a data ecosystem stack, and you see in the top part, these are the computation frameworks, including Spark, Presto, Hadoop, or even like Caffe or PyTorch, this kind of machine learning workloads. And to the bottom, we can see what we call the Android storage or the persistent storage. Alluxio is a bridge connecting the Android storage with this computation. So it provides, you can think it's data abstraction for the data stored physically on the data storage, and then building let the applications, computation frameworks to talk to and to access this data abstraction using the popular and their favorite APIs, including the Java File System API, the HDFS compatible API, or S3 API, or POSIX-based APIs. So Alluxio in here adding a new layer into this stack by providing the data abstraction, but also making the data translated into a format more friendly to be consumed by the applications, and also bring the data closer to the applications to improve the performance. And this is commonly used in a lot of cases where the data and compute are disaggregated. So essentially, the compute has to go and fetch the data remotely and repeatedly. And we see this very common, especially nowadays in a cloud setting where the computation is done in virtual machines like EC2 on AWS versus the data is stored in a remote service like AWS S3. So Alluxio provides performance, provides ease of manageability, and also provides federation of the namespace, storage namespace. But today, I'm going to focus really on the Spark workloads and talk about why people may see benefits from Spark. Well, first of all, if you know Spark, each Spark context is a standalone process, and it's very hard to share the data in memory between different jobs. And if you want to really share data, you have to write data to external storage, and because you can use Alluxio as the in-memory file system, and then this provides a fast speed data sharing approach for different Spark jobs. We'll go through this with more details later. So the next part is the data resilience during application crashes. So especially like in a lot of cases, people are developing their applications. Sometimes they have bugs or they have issues in their runtime, so the Spark jobs can fail and crash, and they lost their intermediate results. And using Alluxio, you can use that as a staging data stage area for your intermediate results. And later on, once you restart Spark application, you can start from there to save the time from scratch. So last, Alluxio can also help Spark jobs consolidate memory usage and alleviate the GC issues. As you may know, Spark is written in Scala and it's a JVM based. So GC is always an issue if some JVM applications is using a lot of memory. So that means you want to really reduce the GC pressure to your processes, and Alluxio can help to consolidate memory usage. Actually, what we'll show today is how, in a demo, is how Alluxio can offload the memory pressure from Spark by storing data in memory in Alluxio space. Yeah. So first, let's see how we can enable data sharing between jobs. So imagine you have two Spark jobs, and one Spark job is writing the output, which is the input for the next stage, for the next Spark. So in a setting, for example, in the public cloud, people typically use AWS or similar services in different cloud vendors as the data lake, and you can just use that to exchange data from one pipeline, from one stage to another. The problem is letting Spark jobs writing, or in general, like application data analytics jobs writing data to S3 can be slower, and it's not very performed, and because there are also consistency concerns. So it's not very ideal if you want to do exchange data in this way. And the inter-process data sharing can slow down also by the network I/O, because during the peak time, you may see a lot of people competing the network I/O to S3. So one way to solve this, you can deploy Alluxio as a staging, you can think it's a staging data area for your Spark jobs. So the first Spark job is writing data to Alluxio in memory, and then the next, it's not necessary to be always to be in memory, but you can also allocate some other storage resource like SSD to Alluxio. But in this picture, I just put in memory there. So the next Spark job can just take the data written to Alluxio. So this data can be very close to both Spark jobs or your computation cluster. And in this way, the data sharing can be very efficient. Note that with Alluxio 2.0, we have also an async persist functionality, which means you can choose whether you want to persist this data in the background to S3. For example, if the first Spark job is writing to Alluxio, and you want the next Spark job to read from Alluxio, then once the data once the first Spark finished writing to Alluxio, the data will be available for the next Spark job. But in the meanwhile, Alluxio can also persist the data asynchronously to S3 by just writing data to S3 without interfering and without waiting, let the second job waiting. So that is basically decoupling the data persist process with the data serving data. So this can be very efficient and very flexible for many applications. Let's talk about data crash. So say if I have a Spark job and I cache my data in Spark. So if you're not very familiar with Spark, essentially Spark can also provide a data cache to some degree by having the data in the local JVMs. So in this way, you can definitely cache the data in Spark, and this can also be very helpful for the later calculations in the same Spark job. The problem is if you have bugs, or if there has some restrictions on the hardware resource or some other issues, so your process get crashed. And that means you have to rebuild all your results by loading the data again from the input data source like S3 and to recalculate the data. So if you crash, and all the intermediate result get lost unless you persist the data to the external storage. So what we can do is you can checkpoint, or you can write your data to Alluxio, which is closer to Spark. And as I mentioned before, Alluxio can asynchronously also persist the data to S3 as you like. And then if your Spark job crashed, in a very unlucky case, you crashed job, and then later on you can just start your Spark job without having the data reloaded from the data source originally and rebuild everything. So you can just start from Alluxio. Yeah. So this is the third case. If you see the storage engine and execution engine, they reading the two Spark jobs are reading from the same input data, and in this case, you also cache the same data twice in the two separate Spark contexts, and in this case, you will just waste, you will just duplicate the memory resource you spent for the same piece of data. Versus in the Alluxio case, you can just make Alluxio to serve the data in memory to both Spark jobs. So in this case, you can achieve the consolidating memory by using Alluxio as the data source. So the API to use Spark with Alluxio is pretty simple, I would say. So essentially, you can access the data directly through the file system API, but remember to use the scheme with Alluxio : //. So that means you don't have to do any code change on Spark or on your application, but only on the data address. And you don't need to, it's very easy to use and don't need to reason about the logic. It just treat Alluxio as an external file system. So as an example, this is the original way you are reading the data from S3 bucket. And then you just simply switch from S3 : // into Alluxio : / with the Alluxio master host name and the port. By default, it's 19998, but you can definitely change the port default service port. So given the master host name and the port, your Spark applications can discover the Alluxio service, and using the Alluxio protocol to talk to Alluxio service, read the data. Spark works with Alluxio clients or Alluxio service out of box. And you just put, so if you have a Spark applications using the default.conf as a configuration, you just put the Alluxio client, the path to Alluxio client inside this configuration file, especially append this path to the extra class path for the driver and the extra class path for the executor. So in this way, Spark will put Alluxio client jar, which is also a Java binary, into its class path, and Spark driver, both Spark driver and Spark executor will be able to talk to Alluxio service to get data and also to query the metadata. Yeah, so if you want to get more details about how Alluxio can help Spark, you can go to this user documentation on the Spark on Alluxio website. So I want to show a few code examples for users using Spark, for example, using RDDs. When you're writing to Alluxio, you just use rdd.save as text file or save as object file, depends on your preference. And with putting Alluxio as the address path there. To read from Alluxio is also very simple. Just use Alluxio as an external file system. So you can just also use the context.text file or object file to read files from Alluxio and construct your RDDs in Spark. I will show this actually in my later in the demo. So people also use Spark DataFrames a lot. So it's very similar. You can so the way to use DataFrames with Alluxio is to put these DataFrames as, for example, the Parquet format in Alluxio. So you can write your data frame, you can export your data frame as a Parquet file into Alluxio space. And you can read it back by sc.read.parquet, and this will get you back, and this will just talk to Alluxio to read the Parquet file and reconstruct this data from Parquet to DataFrames. So you can later on use on DataFrames. And we see different ways people typically ask, like, what's the recommended way to deploy Alluxio with Spark? And we see different ways. So basically, we see Alluxio deployed between Spark and storage, and we also see people co-locate Spark workers with Alluxio, and in this way, Alluxio provides data locality information to Spark, and Spark will be intelligent enough to tell, if I assign the task to this worker, I will get the data locally without using network. So if you really want to optimize your I/O performance, then you can leverage the short circuit read or write provided by Alluxio workers by co-locating Alluxio workers with Spark. And that's illustrated on the right-hand side. And on the left-hand side, essentially, this is another way for people to leverage Spark and Alluxio by having Alluxio as a standalone service. So different Spark clusters, different Spark jobs can read from the same Alluxio cluster, and then they will be benefited from like a previous Spark class or class jobs. Okay, so do we see any questions so far, or any? I'm willing to stop here a little bit and answer the questions.
Sure, Ben, it looks like we do have a few here. So what about data loss during a crash? Do you lose data?
Oh, that's a great question. So it depends on the data, where data is stored. So if the data is stored in the Alluxio and persisted to the physical store already, then there will be no data loss. And if your data is stored in Alluxio, either you choose not persist to the end storage, or it's not persist to end storage yet, then as long as the Alluxio nodes are Alluxio processes are still running, you don't lose data. So the case is you lose both the Spark nodes and also the Alluxio nodes, and basically you have dirty data, and in that case you may lose data. So in Alluxio 2.0, we provide a feature called replicated async writes. So when you're writing data to Alluxio, you can choose how many replications you want. So in this case, you want to write 3 copies into Alluxio. Then before, basically, the 3 copies will be kept before the data is persisted. So in that case, you can tolerate 2 nodes failure. Yeah, so it's all trade-offs between how much resource you want to put and based on how important your data is.
Great. A few more have come in. How does Alluxio do better than having Yarn as a cluster manager where data is already located nearby in HDFS?
Oh, yeah. So I guess the question is asking how Alluxio will work in the case you have a Yarn and a HDFS. So my general answer to this is it really depends on how well your Yarn cluster and HDFS cluster is running. So if your Yarn is running well and the HDFS is also co-located with your, say, Spark workloads, I don't recommend put Alluxio here in this picture. And the reason is HDFS and Yarn can work together to help Spark get data locality. So what we see, most of users using Alluxio benefits from the case they have the architecture where the computation is separated from the storage. So either they don't have a co-located HDFS, so they can have a remote HDFS in a different data center or in the same data center but different places, or they are using that in the S3 on the S3 or some other storage object stores. So that is the I would say more often how user can benefit from Alluxio.
Great. Looks like there's a few questions on setting things up. So what is the recommended cluster manager for Spark when using Alluxio?
Recommended cluster manager. So in the past, Spark, what we see mostly is people are running Spark on their standalone mode. And also in that case, I would recommend to run Alluxio in a standalone mode too. So basically both are in a standalone. In the last few months, we start to see more and more users deploying Spark on Kubernetes. And also we have we also, in the latest 2.1 release in Alluxio, we also provide tools like a Helm chart to help users on Kubernetes to deploy Alluxio. And we have, so Ali, I believe we have quite a few webinars before talking about running Spark, how to run Spark with Alluxio and achieving data locality in the Kubernetes environment. If you're interested, you can go to our website and search for the corresponding result, like resource.
Exactly. You just search for Kubernetes and that will come up, or whatever you're searching for. Okay, Nurali, I'm sorry if I don't understand your question, but I think you're asking if you have a Spark cluster already, do you need to set up your Alluxio cluster where that Spark cluster lives?
If you want to optimize for I/O performance, that's basically the recommendation. Yeah, you want to co-locate your Alluxio cluster with your computation in here, the Spark. But as I mentioned, like we also see in cases, people like performance is less of a issue, but more like a resource efficiency. So they want multiple different applications or even multiple different Spark clusters benefit from the same Alluxio deployment. Then in that case, you just trade off. You just made a trade-off. You trade maybe the best performance to still good, but like a less. Not that bad, not as good as the best performance, but get a much better resource efficiency by consolidating this caching resource.
Great. When you say co-locating Spark and the worker, does it mean to run in the same pod? Yes or no?
So actually, when I see that, we recommend to run this in the same host. I would still recommend to have a Spark worker on one pod and a Alluxio worker on another pod. But there are integrations in the Kubernetes. So I guess this user is asking in the Kubernetes environment, in the context of Kubernetes. And in Spark, there are integration. There is integration so that like Alluxio worker and the Alluxio Spark worker can tell each other, they can tell, we are from the same host, although we're on different pods, but we're on the same host. So let's use some special way to communicate. In here, we can use a domain socket to transfer data with a very fast performance.
Great. What is the recommended size of an Alluxio cluster compared to a Spark cluster? So for example, if your Spark cluster is 50 nodes, do we need Alluxio to have the same amount of nodes?
If you are co-locating Spark with Alluxio, then I guess yes, you should have this as the same. So in this case, Spark can leverage from the short circuit or what I mentioned, like using the domain socket to transfer data for short circuit read and write. Yeah, but if performance is less important, or you have the working set just more than the nodes you can provide with Spark, then yeah, you can use more than the Spark nodes. It's very flexible. It's just like co-locating, making the pool of Spark nodes and the pool of Alluxio nodes overlapping with each other. It's just like maximizing the chance to avoid data transferring over network.
Great. Is there a place where I can find performance metrics when Alluxio is used with Spark?
We have quite a few case studies on our website. For example, so this is from Barclays and from other companies like, for example, Buzzer Voice, they're using Spark. And so later on, we can share this to the website. Yeah.
Great. Okay. Thanks, Ben. I think we can keep going.
Okay, cool. So then let me show you some interesting results by running Spark. Let's get hands dirty. Okay. Okay. So essentially, I launched my terminal to have two different tabs. And one tab is running Alluxio. Well, I haven't really run any Alluxio yet. One is with Spark. Let me just zoom this out. Yeah. So what I'm trying to do here is to do a very simple task. I want to launch Spark first and load data from Spark, and then I will just show you different ways to store this. So let's first launch a Spark shell. So I'm using Spark 244. Give me a second. So I launched a Spark shell here with the driver memory to be 12 gig. So I also downloaded a few sample data, and I have this sample data on with different sizes, 100 meg or 1 gigabytes, 2 gigabytes, and 3 gigabytes. So I will start with a very simple experiment. So because I have already launched this Spark shell, and let's see. Okay, so we have this process ID, and let's run PS to see how much memory it is using right now. So if you can see, 8444 is the process ID, is the PID, and that basically corresponds to this line. And this RSS column shows you how much main memory this process is using. So essentially, the unit is KB. So we are using 744, basically 744 megabytes for this Spark job. Okay, now let's load this data. Let's load the data from local directory. So let's run this. And if you run this again, you will see it's a slightly larger, but it's not significantly larger because nothing has been done yet. And let's do some calculation. So first, let's persist data into Spark local memory without having Alluxio here. So what this will do is to basically put the data RDD loaded into the memory Spark is using. If you do this sample RDD, that's the RDD we loaded .cache, it's basically persisting data into memory. So if you run this again, you will see it's slightly larger. So because it's only like a 20 megabytes larger. So you may ask, like, what's happened? Why even we cache the data in memory, Spark memory utilization, memory usage is not significantly larger? Well, the reason is because Spark is doing lazy execution. So even I typed sample rdd.cache, nothing is happening yet. In order to trigger this to be executed, we have to do some operations like this. So now we run the count. It has about 1 million entries in this RDD. Now, if you check this again, you will see this line where the Spark memory is significantly larger, and it goes up to more than 1.1 gigabytes. And this is because Spark is caching data into the local JVM memory, and that is causing the expanding of the memory usage on the main memory side. Okay, so now let's do the same experiment using Alluxio. So Let's launch Alluxio. So this is a very easy way to launch Alluxio locally. You put Alluxio start local-f, and what this command will do is to launch a local Alluxio cluster on your laptop or on your server by running a local master, local worker with some other processes that you may not need for this specific demos. It will wait for about a minute, for all the processes to complete starting up. And meanwhile, let's start Spark Shell again, and with Alluxio clients as Alluxio client jar on the class path. So you can see, compared to the last time when I launched Spark Shell, I added one more argument, the --driver-class-path. And in this case, we append another Alluxio client jar in here. So this client jar will be on the Spark class path. Okay, so you can see Alluxio finished starting up. You can run the very basic Alluxio commands. And this tells you we have a one node machine with version 2.1.0, and the memory capacity is 10 gigabytes, and 0 byte has been used right now. And you can also check what else in this installation. I think I may have some data. Oh, okay. So let me just remove this data. Okay. So so this is the way you can force Alluxio to remove something. And the reason I see this error, previously the fail to delete, is because I started Alluxio from scratch, where Alluxio sees some data left from my previous runs, and it's warning me because it sees inconsistency between the UFS, the persistent storage, and Alluxio. So with the -u, this will force Alluxio to remove this data, because I know this is just a demo. Like I don't need to worry the data being removed. Okay, now we should see a very clean system. Nothing there. And let's on the Spark side, let's load. Let's load the same RDD again, but this time let's write this data, persist data into Alluxio space. Okay, so you see a warning, but this warning can be ignored. So essentially, we write the data, same RDD, instead of writing a persistent data into Spark JVM, we write this data into Alluxio land. And you can see that it's persisted under the storage, under the directory's cache. And now let's see how much memory Spark is using. So for the so essentially we're using about the same amount of memory as when we are initially start a Spark. Well, the reason is you don't have to use a Spark memory to store the data, and this will and where the data is right now, it's on Alluxio, and you can check how large the data is. see about 100 megabytes stored on Alluxio. So essentially, we're using Alluxio as an off-heap when external in-memory storage for Spark to store the same data without having Spark process to use its own memory, on-heap memory to store this. And this can help Spark reduce the GC pressure and also being able to share this data to some other applications. So that's basically so much for the demo today. Anyone asking any other questions?
Okay, we have a few more questions. Just a reminder, we do have that Slack channel, alluxio.io/Slack, where you can answer questions and connect with our community. So, okay, since you have recommended Spark standalone cluster deployment, how well does Alluxio scale with this? Are there any performance metrics? Because there is some speculation on the capability of a Spark standalone cluster.
I see. We have a lot of internal tests with Spark, with some other applications, and we typically just use a standalone cluster. And what we see, so at least I have seen people running Spark and Alluxio with a reasonable large scale in production, like 100 nodes or thousands of nodes. And so I won't be too scared about the scalability issue with the standalone modes for Spark. Or if you have any particular issues, I'm happy to work with you to see. You're welcome to post this on our Slack channel, and we can work from there together.
Great. When you say to set up Alluxio where we have Spark, will memory available for Spark be compromised?
That's a good question. So in this case, in the demo I showed today, I allocate memory to Spark, to Alluxio. If you see so essentially you can see I do allocate quite some amount of memory to Alluxio, but it's not necessary to use Alluxio to manage memory, and it also depends on where what is the baseline? What is the baseline? If your baseline is really reading or writing to a remote storage like S3, I would say using Alluxio to manage the local SSD or even the hard disk can be already a big win compared to reading and writing over network to S3, and that will already brings you a lot of benefits. So in case you think Spark, your Spark job is very hungry in memory because your workloads, I would suggest to leave memory to Spark or a similar application like a Presto and use Alluxio to handle SSD or hard disk.
Great. Next question from Martin. Hi, Martin. Good to hear from you. Will Alluxio overflow data written to it from memory to disk? And if so, does it relocate all the data to disk, or can files span both memory and disk?
Let me check the question. Will Alluxio overflow data written to it? So yes, so Alluxio provides a concept called tiered storage. So in the tiered storage, you can set up Alluxio with multiple tiers, and if the top tier is filled, and Alluxio can in the background evict data from one tier to the next tier, and then in case like next tier is hard disk, then you can just leave more space for the top tier.
Great. Does Alluxio do well with PySpark, and do we have any case studies or performance numbers?
I haven't really tried PySpark, but I do believe I talked to users using PySpark with Alluxio before. But yeah, on my side, I don't have any experience with that.
Okay. Can this be used for broadcast variable?
So I'm not sure how this. Yeah, I'm not quite sure about it. So I know I'm not very familiar with broadcast variables. So I don't think Alluxio is a good use case for that.
Great. All right. Any more questions before we wrap up today? And I just put the Slack channel in chat. Sorry I didn't do that earlier, but there's your access to it if you want to join. We have our community there, Ben's there all the time. Many of our engineers are there answering questions at all times during both day and night. So it's a great place to connect with community and get your questions answered. So with that, I think we answered a ton. You answered a ton.
Yep.
Today, looks like we might have just gotten one more. Will the presentation be available? Yes, it sure will. We will send an email out afterwards with both the recording and the slides. So with that, thank you everybody who attended. Thank you, Ben, for the great content, and we'll see everybody next time.
Thank you, everyone.
Thanks.